who's a member of ISOC and lives in Slovenia. And he's here to talk about NAT64 and DNS64 real-life experience. Give him a welcome, please.
Thank you. Hello. My name is Zorz. Alan, thank you for the introduction. I work for Internet Society. I'm coming from Slovenia. Thanks to Christian for being so persistent for so many years to actually get me here. I'm happy that you invited me. I spent last 16 years or 15 years with IPv6. I'm coming from operational part of the world, despite me working for ISOC. Building, running the network, keeping my hands dirty. And out of these long years of experience, we built a lab as part of Go6 Institute, the not-for-profit organization in Slovenia, to promote IPv6. I'm still running the Go6 and Go6 lab, where we are doing lots of IPv6 stuff, experiments, also DNSSEC stuff, DANE, TLS, and such things. This talk and this topic comes out of my travels around the world, talking to operators, and actually discussing with them what sort of issues they have while implementing IPv6. And when I see the pattern, then I ask myself, how can we go and help with this issue? And lately, talking to mobile operators, it came out that NAT64 is the thing that mobile operators are using for mobile devices to access IPv4. I hope that everybody knows how NAT64 works, because I will not explain it here. But there are some issues. Operators are concerned about the user experience, and they're concerned about how their users will see the content on the interwebs. So this is the product from Sander and me. So let's head to the problem statement. Let me walk you through all 6 degrees of inner turbulence that I had while discussing this stuff. IPv6 and IPv4 are incompatible on the wire. Full stop. They're incompatible on the wire. They're like ships in the night. So we need some translation and transition mechanism, right? And as I said, mobile operators are massively switching devices to IPv6 only. For example, T-Mobile USA only has 52 million devices on IPv6 only. There is 52 million potential eyeballs that maybe will not see your content properly. This might be a problem, right? So if you're using 464 XLAT, what can happen to us? Let's have a look, because we saw that some people does weird stuff while putting quad A for their servers in the DNS. So there are some important questions. Do content providers understand how their content will be seen through NAT64? And do connectivity providers know what their users' experience will be? Okay, first of all, some acknowledgements. I would like to thank Internet Society for dedicate lots of my working time to do these sort of experiments in the lab and then talk about it around the world. I would also like to thank Go6 Institute in Slovenia. They're providing the lab and the hardware and the whole thing. Sander Stefan for his working time, coding skills. He's basically a Python guy that coded the NAT64 check, the tool that I will explain later. And of course, Corinne Pritchard, his girlfriend, for lovely design of the tool. Hugs to Corinne. Okay, so first of all, before building the tool, we set up a NAT64 testbed in Go6 Lab. So if you go to this URL, there are instructions how you can remotely test the NAT64, any of implementations that we are running on the lab. Because we put the NAT64 prefix is a globally routable prefix. It's not some internal one. It is a globally routable prefix. So the DNS64 server is actually synthesizing the quad A's with the globally routable prefix. So if you have IPv6 here, and you set the DNS to my DNS64 back in Slovenia in my lab, you will start sending packets to NAT64 implementation in my lab, and you will see how the whole thing works. It is not meant for performance testing because it's remote, but it's more meant for sort of like services testing, and that you can get some sort of experience of how NAT64 looks like. We have 4 of them currently. Everything is explained on that link. So you can do the test. I think even Google, I got an email from Lorenzo one day saying, Jan, thank you for running all these implementations in your lab. We tested the 464 XLAT for Android implementation that is turned on by default these days. We actually tested it against your lab and found some bugs in the code with one of the implementations, and we actually fixed the code, and now it's fine. So if you're a service provider, or if you write applications, you can test remotely how your application behaves behind the NAT64 environment. Right. So this is the URL that I talked about, and here you have instructions how to actually see. You have 810 networks, and you set your DNS to this IP. We have Palo Alto firewall. You set the DNS to this one, and then you will send packets to this NAT64 implementation. We also have YOL. That's the open source implementation of NAT64. It's kind of cool. It's a module in Linux. And we also have Cisco sent us ASR1K, just to do various things in the lab. This is this is the lab. So this is actually the hardware. It's not something virtual. This is my lab. Sander calls it a systematic chaos. That is. But yeah, so we have 2 Palo Alto 10 gig boxes. Me personally, I'm mostly using this one. Okay. What did we discover with this test setup? Because I'm from time to time looking at the logs, what is going wrong, and looking at specifically the DNS64 logs is kind of amusing. Because have you ever seen any of these early values for quad A record? You wouldn't believe, but people actually do put column as the quad A record. Some people put in column 1. Some people put in double column FFF column something. Then we have FA80. We have 64 FF9B. And also the documentation prefix. People, this is not going to work. Really. Especially if you go through NAT64. Because then, if you put the quad A record into the DNS, NAT64, a DNS64 will not synthesize the quad A for you. And you will be unreachable. People will just not reach you. People will not see your content. Think about 52 million people just on the T-Mobile USA, and there is Verizon. There are other mobile operators that are doing it. So, if you have seen something like this, and you know who did it, call him and tell him to fix it. This is not making internet any better place. Actually, Dan Wing is doing the quad A stats, and you can see a lot of weird things in there. Okay. Then what we observed was a confusion with or without www. So for example, this one is an alias, and then they have this one, and then if you go host firstinside.com has the address of column. Well done. And then, let's break all illusions. This is not going to work, right? This is not going to work. Right. Okay. So when you build this, build me up, break me down. So what can we do about it? In our tool that I will talk about later, we are not masking these problems. I will talk about this later. But we can figure out who these people are, warn them about the issue, and remember, if you are not part of the solution, you are part of the problem, right? And at the same time, if you want to keep your customers happy, if you are the connectivity provider or mobile operator, we figured out that you can put the exclude rules in your DNS64 configuration. So whenever there is a quad A record that has any of that crap in it, it will just ignore it and synthesize the quad A record based on IPv4 record. How do you do this? Simply. You know, some of you who knows me, you know that my presentation cannot go without the configuration in it. So here it is. This is for bind 9. And actually, what we did before was I went and excluded all these weird things, but then I figured out that there are too many of them. So IANA allocated 2000:3 as the global routable prefix. So what I did was I just broke down the whole thing and just excluded 0:3, 400:2. So if there is quad A with value that is coming from anywhere outside 2000:3, it will be just ignored, because that is not supposed to work. Okay, so this fixes the most common errors, right? And this also prevents issues when the quad A actually contains something that is outside the quad A, the 200/3 block. But there is a slight moment of betrayal. I'm a big fan of DNSSEC. But DNS64, it synthesizes the quad A. It makes them up. So if that domain is DNSSEC signed, there is no way to create a signature for that made up quad A record. So there we have break DNSSEC configuration directive in the DNS64 configuration, and you need to set it to yes. That means that the DNS server itself will try to validate the IPv4 record and then synthesize, but it will not tell you as the client that this is DNSSEC signed. It will not. So if you're using the normal client on your PC or Mac, these normal clients usually are not validating towards the recursor. But if you will use DNS recursive server in your home and point it to the DNS64 DNS server, it will just not validate. But it is what it is. This is designed to be like this. It should not be a big problem, but you know, it hurts a little bit that you have to break DNSSEC. So here is, if you ask the DNS64 server that has without break DNSSEC yes, you ask it for quad A for 4.go6.si, that is only a record, and it will just not serve you anything, because if you're not breaking DNSSEC, it will just not serve you anything. When you put the break DNSSEC sentence in the configuration, then you see that you will get this quad A that consists of NAT64 prefix plus IPv4 address in hex. Yeah, it's a sort of enigma machine, but we'll have to live with it. This is also the unbound example of DNS64 configuration. You see here, I was excluding everything, but then I just decided to exclude everything outside 200/3. There is more reading available on DNS64 and DNSSEC. There is an RFC from Illich and other people that explains how exactly DNSSEC and NAT64 works together. Right, let's go to some examples. What we observed. We have firewalls.com. It's not some naming and shaming here, right? Still waiting for that timeout. Indeed, it's very secure. Very, very secure. What is this? What the heck is this? All right. It's firewalls.com. It must be secure. All right. Then we have some Spanish people. What do you have on IPv6 and NAT64? Something completely different. This is not going to work. If people has IPv6 and they will reach your web server, this is what they get, not that one, right? Not good. And I think this is something from the government. Well done. Okay, then we have from Slovenia actually. Shrani SE, that is sort of like it's a huge online disk station basically, and this is the geolocation. Here it says, okay, you are well, you are done, but here it says that pictures and videos can be only loaded from Slovenia. Well, I am in Slovenia. I'm sitting in my lab, for God's sake. So they need to fix this. Okay. This one is also weird. There was no quad A, but server is still confused. This is uc.cn, and through NAT64 you get this instead of these pretty pictures with squirrels. I'm not sure which one I like more, but right? Okay. Then we have a good server and bad content. You see, if they want to sell you something, you need to see pictures, people, pictures, right? If you have a shop, this is not going to help you sell more things. More stuff coming. Also here, I don't know what these people is doing, but this is not going to help a lot. Okay. We already discovered that if you have a not working quad A record, you get a broken NAT64. So this is a tool that I will talk about. This tests the whole thing. So if for example, this is sort of like a valid quad A record, and it also replies to IPv6 pings. But if there is no web server running on IPv6, is this actually not going to work, right? No. And if this thing happens, also people from NAT64 will not access your content because DNS64 will not synthesize the quad A record for you. People will not see your content. Then we have sort of like bad gateway. We have a working quad A record and IPv4 only content. So, and then, you know, things breaks. So here, if you go in our tool, if you press that little triangle, it shows you all the elements in website that loaded on NAT64, on IPv4 only, and on IPv6 only. So this is probably not going to work well. So let's discover this looking glass. There are many things to test. We have to test NAT64, test on IPv6 only. Did all resources load okay? Does it look good to the user? Do we see any path MTU issues? So This all started then with me as a really, really bad coder. I'm not a coder. I do stuff in bash scripts. And I put together some prototypes of how to test all these things. And then Sander Stefan saw my code and he said, "Sir, step back from that code." And he actually coded the whole thing in Python. We called it NAT64 check. What is it? It is on nat64check.go6lab.si. It's open, it's free, everybody can use it, lots of people is using it and putting tests in. And here, you just put in your URL that you want to test and press check button. And here is the list of the measurements that were already done in the past. You can also use the filters. So if you press here for good, then you get only IPv6 and good. You have then only pages that were tested and IPv6 was good. You can press, I don't know, NAT64 good or NAT64 poor or mediocre, so you can sort out the results. And then when you get the result, you can do the mouse over. And you see, you can do the mouse over and it will tell you the visual difference on how people from NAT64 environment are seeing it versus IPv4 only environment. And same goes for IPv6 environment, right? You see? First of all, there are some lines in the sand that we don't cross. We don't fix brokenness. With this tool, we did not put the exclude statements in the DNS64. If you have a broken quad A record, you will figure it out. Absolutely. It will probably be red blinking stuff on the result page saying, fix it. So these are, currently we have two instances. One is running in Go6 Lab and one is running in Sander's lab, IPv6-lab.net. Use one or the other, or both. So let's go a little bit under the bonnet, a little bit of illumination theory. How does all this thing works? We have 4 servers. We have management server and web interface. That is the one that you actually access when you type in nat64check.go6lab.si. And then we have one server with IPv6 only environment, one with IPv4 only, and one with IPv6 only plus NAT64. And actually, we are using Phantom.js as a command line browser to keep track of all loaded or not resources, and we make a screenshot. So we are not faking the environment. We are actually running the web browser in that environment, and we make a screenshot of whatever came back over the net. And then we compare images with each other, and we check for resources that could not be loaded. Okay, some images and words. That's the master server. This is IPv4 only, web client, IPv6 only, and NAT64. That's DNS64 and NAT64. And the whole thing works together. Please, when you press that button for the measurement, take some time. Take the time, because it's quite a lengthy process. Maybe, I don't know, 10, 20 seconds, because the master server needs to send the command to all the servers. They need to fetch all the data. It needs to ping. It needs to do the path MTU discovery, issues discovery. This takes some time to render the picture. Some images and some things may not load. So take the time. Be patient. It will show you when the test is finished. Don't press the button gazillion times. It will not help at all. It is sort of like the thing that people press both buttons at the elevator in secret hope that the elevator will arrive faster. It will not help, right? Okay. You will see this for some time, so please be patient. Wash, rinse, and repeat? Yes. If you discover that your content or somebody else's content is broken, fix it until you have a good result on our tool. You need to be sure that all the images load over IPv6. Usually it's the problem for these scripts or these scripts that makes your page look good. Usually people load them from somewhere else, and then they don't load on IPv6, and then your web page looks like crap. You need to understand that DNS64 will fail. It just depends on you in which way it will fail or not. And when you fix the whole thing, test again. But please keep in mind that DNS, if you have problems with DNS needs some time to refresh. And there are TTLs, so you need to give it some time before you test again. And repeat until your website is no longer broken. So, for example, these are things that we see in the DNS64 logs. If you don't have a fully functional domain, it will not work. In IPv4, you may get away with it, but here, no. For example, error resolving ns1.qq.com. qq.com is not subdomain of zone ns3.qq.com invalid response. This will not work. This will just not work, right? We are always in constant motion, and the code for this system is on GitHub. It's free. Please, if you're interested in this stuff, help us develop it. You can also set up your own instance of all these servers and the tool. If you do it, please tell us. We will put it in the list of instances. The more instances we have around the world, the better it is, right? And Sander is actually maintaining the whole stuff. So the conclusions. We need to make sure that the spirit carries on. And if you're a content provider, test how people see your content from a different environments. If you're a connectivity provider, test how your IPv6 only customers will see what will be their user experience. If both, all of the above, and you might be surprised. Well, you probably will be surprised. Here are the links if you want to test the tool. And if there are any questions? You are enchanted.
Is this thing on? Yeah. Do we have any questions?
I see confused faces. Yo.
Like many big organizations, I have great confidence in our IT department. And what may work today may not work tomorrow. Would it be feasible for you to extend the tool in such a way that not only I can verify if today the website works on both v4 and v6 and behind net and whatnot, but if that changes, that it sends me an alert saying, hey, something changed, your screenshots are completely different, so maybe roll back to maintenance. And you wouldn't need to check every 5 minutes. It's not an uptime thing, but if you check like once every 24 hours, I think that would really help make consistent operations with v4 and v6, because many people get it working, put some ping monitoring on it, and never look back. And this is a very good test, I think, for such a purpose.
Short answer is yes.
Thank you.
A bit longer answer is we are more than happy to receive any suggestions how to improve the tool. We're in constant motion. We will add functionalities to the tool. We also had this discussion about email testing on IPv6 and all this stuff. So if you have any suggestions, please, we are more than happy to make a list of suggestions and then try to implement them.
one addition. Should you implement the monitoring feature, I think it's worth money.
Okay.
So if you charge me $5 per month for this, I think that's reasonable.
Thank you very much.
It's a good suggestion.
Well, Job likes my tool.
Is there any other questions?
I see confused faces. Okay.
Is anybody considering implementing the DNS64 and NAT64?
Just like to say.
Okay.
I would applaud people to go in and actually look at the link right now so we can shame some people that's actually in the room right now, because we can see that TDC, Gigabit, Hyper, and people are testing their home pages right now. So maybe we have something to talk about in the next break.
Okay. You know, the good feature of this is that there are measurements listed on the first page.
All right. That leaves us comfortably ahead of our schedule, which was why I was unsurprised to hear, I was a bit surprised to hear the questions already. Next is a very good point called break.
Okay,
And so
thank you.